As you can see that this geometry is preserved here, and we are using the duplicate file of this geometry. And in the case of any accidental changes in geometry, we can always restore geometry from this container here. The next thing is that we are going to solve this problem in the Fluent. So I will be making the cell for the Fluent. So just drag the fluid flow cell over here and link the geometry with the link cell in the fluid flow that is with the Fluent. And here I'm going to double click on the mesh. So I'm basically interested to get the CFD mesh for this whole domain. And then we apply the boundary conditions, solve this problem. And then we come back for the static structural, that is the solution inside the Ansys mechanical. So now we have this meshing application is now open. Alright, so first of all, we have to select the meshing method, and for that we have to choose the geometry, insert, and the method would be this will be equal to the tetrahedrons. Okay, second thing is that you should make sure that the Fluent is selected and CFD also selected for the physics preference. And sometimes by default we have the mechanical here, so just change it to CFD and solver to the Fluent. Okay, next thing is the sizing on these surfaces. So now just take an example. This the size of this geometry on this inlet face is equal to the 800 on the one side, of this will be equal to 1600. And if we divide this by the 10, so we get the 160 elements on this surface. But if we divide this by the 20, so we will get the element size equal to the half of that value, which is equal to 80 nodes will be on this surface. So I will be putting the size as the 20. So 20 for all these surfaces here. And if you find that this size is not appropriate for your purpose for your CFD analysis, you can always open the Ansys meshing application and change the sizes and see the sizes if they are okay or not. Okay, this size is very small, so I think we should be going with the element size I'm going to put is the 20, and click on generate. As you can see, the size is very fine, so I will reduce the size to the, let's say, to the 40, and again click on generate. Okay, so this size seems decent here, and I will be hiding these faces, also this one, and this one. And then right click on the mesh and click on the clear generated data. Okay. So next thing is that I'm just going to define this sizing on this geometry on both sides. And the sizing I'm going to use, let's say, is equal to the 2. So now let me try this sizing and see how this will look like for this geometry here. This is the cooling tower outer part. Okay, so we have some problem here. Okay, again click on the generate. Okay, so I just changed the view into the wireframe, and show mesh is displayed. You can also hide it. And now simply click on the surface and you will get the mesh. How this now you can see this mesh is a decent mesh on the geometry. Okay, so this is the mesh for this outer boundary, and the same mesh would be for the inner boundary. And then we will see the mesh on the top side, which is also is a good enough. So this mesh is okay. Okay, now again I will be hiding this part as well. And click on this command, and again I will be hiding this face as well. Okay, now from the bottom side, this is also a decent mesh sizing. Okay, next thing is I'm going to define the sizes on these parts. So for that, I am just going to use the name selection. So name selection is sizing, and then I will use the name selections, and name selection would be the cooling tower supports. And the size I'm going to put is the 0.5, and then click on generate. And you can see the size for this mesh here. So this mesh is not decent mesh here, and so I would be defining size smaller than this size. So let's say I put the size as the 0.2, and also inside the meshing and then sizing, put the default deficient size equal to the 0.1. And again now click on the generate so that we can see the mesh after refinement on the bottom side of the geometry. And there it is on the supports. Okay, so again I will zoom these support parts, and I think this mesh is okay. See the bottom side, which is also okay, and then the top side, and the outer part, and then the inner part. And also these boundaries. So now let me check the size of the mesh. Okay, the mesh size is equal to the number of elements are equal to the 2.5 million. Next thing is to include the inflation layers, and I'm going to use around 10 inflation layers, and that will be so you can also use the name selections. So this is going to be okay, so this is the geometry we are going to select from a screen, and I will choose the name selection for the boundaries, and these boundaries are the bottom and the cooling tower, inner, outer, top, bottom, and supports, and number of layers would be equal to the 10 or maybe 15, and then again click on generate. And here is the mesh on the cooling tower bottom side, and overall mesh size is equal to the 4 million nodes, 4 million cells, and 1.5 million nodes here. And you can see the number of prism layers are can see from here are 15. Okay, so we are done with the meshing for the CFD part. So just close down this meshing application. And next thing is to set up this problem in the Fluent and then solve it at the required boundary conditions. And then we switch to the Ansys structural part. The last thing in this video is to update this mesh file. This is very important step. Alright, so the next video will be on the Fluent part where we'll set up the problem and solve